Alright, today we are finally going to do some indoor navigation. Get hyped. So first of all, we need to scan all the areas that a user may localize in. So we'll scan all the entrances and common areas. Now we'll walk to our destination and drop breadcrumbs as we go so we have a clear walkable path. We can mark the destination and then keep walking to all of our start points to make sure that they also have a path to the destination. So now we save the map and it writes everything to the server. Now we can open the app in any of the areas that we previously scanned and the device will localize. The A-star navigation algorithm runs to find us the shortest path to our destination using all the nodes that we saved previously. We don't show the whole path because we don't want everything to show through the walls. To cheat occlusion in a way, we'll just activate the next node in the path as we walk to our destination. Alright, sorry this video took so long. I've had the project done for a while, but I've just been drowning in homework lately. Anyway, in the last video, I naively committed to doing some indoor navigation, having no idea how the solution was actually going to pan out. The first thing we need to consider is, how are we going to localize our device indoors without using GPS? This is the same problem that prevents multiplayer AR experiences from being easy to do. Basically, we need to figure out a way to map an indoor area. Then, when we start the app on the phone, it needs to be able to figure out where it is relative to that map. So research tells us that there's a few ways to do this. We can use Bluetooth beacons, we can do RSSI fingerprinting, or we can use computer vision by way of an augmented reality SDK to map the environment. With Bluetooth beacons, the basic idea is to put a bunch of them in an area and then calculate your position based on the IDs and received signal strength, or RSSI, of the Bluetooth beacons. But that's out just because it's out. We're not doing that. RSSI fingerprinting, on the other hand, uses Wi-Fi, and the basic idea is to map an area by walking around and taking RSSI readings everywhere, creating a grid of nodes that each have a signal strength and a MAC address attached to them. So when you open up your phone, you can use the current MAC address of the connected access point and its RSSI value to figure out which node you're closest to. While we aren't going to do this today, I am doing a project on this for my wireless networking class, so we'll probably explore this in a future video. My experience with this so far is that it's really not accurate, and also it only works on Android because iOS doesn't give you access to networking information. The third method is what we're going to use today, and that is using an augmented reality SDK to map an area with computer vision and then save that information so we can relocalize within it later. ARCore for Android has their Cloud Anchor feature, and ARkit has their AR World Map feature for saving maps. ARCore allows their Cloud Anchors to be viewed from iOS, so I thought this would be a good cross-platform solution. Once we have a method for localization, we can move to the next step, which is we need to be able to save a walkable path within the map that leads to our destination. So this way we can display the best path for the user. The easiest way to do this seems to be dropping waypoints as you map the area, like breadcrumbs, except for you drop them along every possible passageway. It quickly becomes apparent that you need some kind of cloud storage, not only to save the map, but also to save X number of waypoints and their locations inside each map. Now, I remembered my buddy Salty telling me about an SDK called PlaceNote. I figured I better investigate that before I start, because it's super important to check out all possible solutions before you embark on a project, because you don't want to end up reinventing the wheel. It turns out PlaceNote is an SDK for creating persistent AR that integrates with ARkit, and also has a nice cloud-based solution that goes along with it. So this is great for making multiplayer experiences, for tagging messages in particular areas, or in our case, indoor navigation. So this is different than using ARkit 2.0 and their AR World Map, because PlaceNote takes care of cloud storage for us. So as we said before, you need to be able to upload and store information in addition to your map of the room. PlaceNote allows you to easily serialize and upload content along with your map. Now, we could make this app with ARCore and their Cloud Anchor feature, but the same problem exists, where we need to create our own kind of like server backend for storing the map and its associated data. Also, ARCore only allows you to store your Cloud Anchors for like 24 hours, which is okay for making multiplayer experiences, but it doesn't really work for indoor navigation. So I ended up making a little indoor navigation demo with PlaceNote, and that's what I'm going to show you guys how to use now. Unfortunately, it's only going to work for iOS. Don't be mad. PlaceNote is supposed to come out with an Android solution, but I don't know exactly when. If you want to talk to some PlaceNote devs, or you want to annoy the team about the Android version, check out placenote.com/Slack. Now, I am super busy with school right now, but I should be done like early December, so I'll look into doing an Android version at that point, whether it's with PlaceNote or ARCore, so stay tuned for that. Anyway, to get this app working on your phone, we first need to get the project. So go to my GitHub and find the Indoor Nav PlaceNote project. Download that and open it up in Unity. My last commit was with Unity version 2018.3, so try to use that version if you can to avoid problems. Now we need to sign up for PlaceNote and get a license key. So go to placenote.com and create an account. Once you're logged in, go to API keys and create a new key. Copy that key to your clipboard. If you click on the Places tab, this is the cloud storage area that I was talking about earlier. You can see all the different maps that you saved, and if you click on one, you can see all the metadata that gets saved with each map, like your GPS location and even the JSON that contains your waypoint information like type and position. If we go back to Unity, you can go to PlaceNote and Scenes to find the PlaceNote sample scene. If you build this out to your phone, you can see what PlaceNote is capable of. This scene allows you to save and load multiple maps. So in my project, I basically split this into two scenes, one for creating a map and one for reading the map. I figured you guys would be using this for like school projects and stuff, so you yourselves could use the create map scene to make the map, and then for whoever's going to actually use and evaluate it, you would just build them out the read map scene. Hopefully that makes things easier. So if we go to the scenes folder, you'll see a create map scene and a read map scene. Before we forget, let's open up each one and paste in your license key on each PlaceNote Camera Manager object. Open up the create map scene. This scene allows you to save a map and drop all of the waypoints. So if we open up that create map script on the main panel, this is where all the magic happens. Now you can save multiple maps with PlaceNote, but in this implementation, I just rewrite the same one every time for simplicity in the UI. When you use this scene, make sure to get a good scan of the room where you start and then hit create a map. This allows you to start dropping waypoints as you move, which happens down in the update function of the createmap.cs script. It should be noted that you only have to fully scan rooms in which a user may localize in. So in hallways and corridors, you don't have to worry about getting any feature points. Now, if we go to the read map scene and find the main panel, the read map script is where the map gets loaded from your PlaceNote account. If you go down to the find map function, you will see that I'm using libPlaceNote to search for a map by name. But one of the coolest things about PlaceNote is that this search maps function has a bunch of overloads, one of which is that you can search for a map based on GPS coordinates. I thought this was super cool. If you have a bunch of places mapped because the user doesn't have to find the map they're closest to, you can do it all behind the scenes. Now, one important thing that I forgot to do was give the user some feedback when localization occurs. Right now, only the first arrow shows up, which is only useful if you're looking in that direction. So if you look to the bottom, there's an onStatusChange callback that loads the shapes upon localization. It may be useful to display some kind of message to the user when that occurs so that they know to look around for the first arrow. Now, the last important piece of this project is the pathfinding piece. So if we go to the scripts folder, you will see an A* script. This is just an implementation of the A* pathfinding algorithm that takes in a list of nodes as well as a start node and a destination node. It then outputs the shortest path between the two. The node script goes on each waypoint and is responsible for finding all of its nearest neighbors. The A* script uses this information when traversing different paths before it finds the shortest one. So the nav controller script is what goes on the main camera in the read map scene, and it's responsible for initiating the navigation, and it uses collisions to activate the next node in the path as you walk around. So one big issue I was having was that the A* algorithm wouldn't always return a path. This was because each node didn't always have neighbors that led to the destination. So to alleviate this issue, I recursively run the A* algorithm, increasing the distance that each node searches for its neighbors until a solution is reached. So if you don't create a destination node when you're creating a new map, you will have many problems. If you want to test the navigation stuff, I have a game object that's currently disabled in the scene. Just enable that and click play, and you can move the camera around to see the behavior in the editor. Don't forget to disable this before you build, or else the app will basically explode. Now, to get this on your phone, go to player settings and make sure you put something in for the bundle identifier. Also make sure you have something for a camera usage description as well as a location usage description. So when you open it up in Xcode, everything should be set. But at some point, I updated the PlaceNote SDK mid-project, and the link to the PlaceNote framework broke. So make sure to relink that. Also, make sure that you're not on iOS 12. I've only tested this on iOS 11, and on their website, it does not say anything about iOS 12 support. So if you are on iOS 12, just be wary of that issue. All right, so that's it. That's all I got for today. Let me know in the comments if this helped you out. If you have any questions, let me know. And it's going to be a while till I get to do my next video, but I'll probably try to explore some kind of solution like this for Android, whether it's with ARkit or PlaceNote, or maybe we try that RSSI fingerprinting stuff for Android. So I'm not entirely sure, but let me know in the comments what you guys want to see. And with that, I'm going to go torture myself with some more homework. So we'll see you in the next one. Goodbye.